Imagine waking up one day to find your phone's GPS completely useless, satellites falling silent, airlines grounding flights, and the northern lights dancing over places like Florida and Australia. Sound like science fiction? It's closer to reality than you might think. And it all has to do with something invisible happening right now, 3,000 kilometers beneath your feet. Welcome back to the channel. Today, we are diving into one of the most fascinating mysteries unfolding in 2025, Earth's weakening magnetic field. Is our planet's protective shield actually collapsing? Let's get into what scientists are discovering right now. Here's what's happening in 2025, and it's more dramatic than you might expect. The European Space Agency's swarm satellites have been monitoring Earth's magnetic field for 11 years now, and the data they're collecting is raising eyebrows across the scientific community. According to research published just this year in Physics of the Earth and Planetary Interiors, there's a massive weak spot in our magnetic field called the South Atlantic Anomaly, and it's growing fast. How fast? Since 2014, this weak region has expanded by an area nearly half the size of continental Europe. That's roughly 5 million square kilometers of weakened magnetic protection. The anomaly stretches from South America across the Atlantic Ocean, and now it's reaching toward the tip of Africa. But here's what's really concerning. Since 2020, a region southwest of Africa has experienced an even faster rate of weakening. Professor Chris Finlay from the Technical University of Denmark explains that the South Atlantic Anomaly isn't just one uniform weak spot. It is changing differently near Africa than it is near South America, suggesting something complex is happening deep within Earth's core. This isn't just theoretical. Right now, satellites passing through this region face higher doses of cosmic radiation. The result? Hardware malfunctions, system failures, and in worst-case scenarios, complete satellite blackouts. As our world becomes more dependent on satellite technology for communications, GPS, and Earth monitoring, this growing weak spot poses real challenges. So what exactly is Earth's magnetic field? And why should we care? Imagine Earth surrounded by a giant, invisible bubble extending thousands of kilometers into space. This is our magnetosphere, Earth's protective magnetic field. It's generated by something remarkable happening in our planet's core. About 3,000 kilometers beneath our feet, there's an ocean of molten, swirling liquid iron. As this superheated metal churns and flows, it acts like a giant conductor. Think of it as a massive bicycle dynamo. This creates electrical currents, which in turn generate our electromagnetic field. Under normal conditions, Earth's magnetosphere extends 8 to 11 Earth-rad into space that is between 51,000 and 70,000 kilometers. This invisible shield deflects charged particles from solar wind and cosmic radiation, protecting our atmosphere from being stripped away and shielding life on Earth's surface from harmful radiation. But here's the thing. This process is far more complex than it sounds. The flows in the outer core are turbulent, chaotic, and constantly changing. And right now, something unusual is happening. In the South Atlantic region, scientists have observed something strange. Normally, magnetic field lines should be coming out of Earth's core in the southern hemisphere. But beneath the South Atlantic Anomaly, the magnetic field lines are actually being drawn back into the core. They're reversed. One theory suggests there could be a massive anticyclone in the southern portion of Earth's liquid metal outer core, pushing the magnetic field out from this region. Another possibility is that there's essentially a mini polarity reversal happening in this specific area. While the South Atlantic gets weaker, something equally dramatic is happening up north. The magnetic North Pole is on the move. Since it was first discovered in 1831 by explorer James Clark Ross in northern Canada, the magnetic North Pole has been slowly drifting. But in recent decades, that drift turned into a sprint. By the 2000s, it was moving at about 31 miles per year, racing towards Siberia. Then something unexpected happened. In the last 5 years, the movement has slowed to about 22 miles per year. According to William Brown from the British Geological Survey, this is the biggest deceleration in speed scientists have ever observed. As Brown puts it, the current behavior of magnetic north is something we have never observed before. It's not just about movement. The strength of the magnetic field is shifting globally. Over the past decade, the magnetic field over Siberia has strengthened by an area comparable to Greenland. The strong field region over Canada has shrunk by an area nearly the size of India. Meanwhile, the South Atlantic Anomaly continues to expand. Every 5 years, scientists release an updated world magnetic model, a critical tool used by GPS systems, aviation, shipping, and military operations worldwide. The 2025 update confirms these dramatic changes are continuing. This brings us to the big question everyone is asking: is this leading to a magnetic pole reversal? A flip where north becomes south and south becomes north? The answer is complicated, but let's break down what we know. Earth's magnetic poles have reversed hundreds of times throughout our planet's 4-5 billion year history. By studying ancient volcanic rocks and sediment cores from the ocean floor, scientists have discovered that reversals have occurred about 100 times in the past 20 million years. The last major reversal, called the Bruns-Machiyama reversal, happened between 772,000 and 780,000 years ago. Some people claim we're overdue for a flip, but geologists from institutions like the USGS emphasize that reversals don't follow a predictable schedule. Sometimes they happen every 10,000 years. Other times, gaps stretch up to 50 million years. Here is the crucial data. Recent expert assessments from 2023 to 2025 put the probability of a reversal occurring within the next 20,000 years at just 2%. That's extremely low. Moreover, Chris Finley's 2025 study found no signs of an impending reversal. As he explains, we know from paleomagnetic records that Earth's magnetic field has weakened many times in the past, displaying weak field regions like the South Atlantic Anomaly without reversing. Instead of full reversals, Earth's magnetic field often goes through excursions, events where the field weakens significantly, wanders, and then reestablishes itself. These are about 10 times more common than full-fledged reversals. According to paleomagnetist Robert Coe, in the last 50,000 years, there were many times when the field strength was a lot lower than it is today without reversing. Even if a reversal were to begin, it wouldn't happen overnight. The process takes thousands of years to complete. The magnetic field would gradually weaken, become more complex with multiple poles, and only then would it complete the reversal. This is a geological timescale event, not a human timescale catastrophe. But we do have a recent example of what happens when Earth's magnetic field dramatically weakens. And remarkably, humans not only survived it, we adapted. Around 41,000 years ago, Earth experienced what's called the Laschamps Excursion. The magnetic field weakened to just 10% of its current strength. The magnetic poles tilted by up to 76 degrees from the geographic poles. Earth's protective magnetosphere shrank dramatically from its normal extent of 51,000 to 70,000 kilometers down to just 15,500 kilometers. A groundbreaking study published in Science Advances in 2025 reconstructed what this meant for our ancestors. The research team, led by Agnet Mukhopadhyay from the University of Michigan, discovered that the auroral ovals, the regions where northern and southern lights appear, expanded from less than 3,000 kilometers in diameter to over 8,000 kilometers. Auroras appeared over places like northern Africa, Australia, and New Zealand, regions that never see them today. Archaeological evidence reveals fascinating changes in human behavior during this period. A noticeable increase in cave habitation, suggesting early humans sought shelter from elevated radiation levels. Caves that were previously used intermittently became primary living spaces. The researchers found intriguing correlations between areas affected by auroral coverage and archaeological evidence of human adaptations. Meanwhile, this period coincides with the decline of Neanderthals in Europe, though scientists caution against drawing a direct causal link. What's clear is that Homo sapiens showed remarkable cognitive flexibility, adapting, innovating, and ultimately thriving despite the harsh conditions. So what does all this mean for us in 2025 and beyond? For satellites and space technology, right now, satellites passing through the South Atlantic Anomaly experience higher radiation exposure. This leads to increased hardware failures, shortened operational lifespans, and potential blackouts in communications. The International Space Station experiences higher radiation doses during passes through this region. For aviation, airlines, especially those flying polar routes, need to account for increased radiation exposure for crew and passengers, potential navigation system disruptions, and the need for more frequent updates to magnetic navigation models. For technology on Earth, GPS systems require constant updates to remain accurate. Power grids could become more vulnerable to geomagnetic storms. Communication systems may experience more frequent disruptions. If the magnetic field continues to weaken, computer models suggest that major solar storms could destroy up to 40% of Earth's ozone at high latitudes for months to years at a time. Scientists aren't sitting idle. The ESA's SWARM mission, now in its 11th year, provides the longest continuous record of magnetic field measurements from space. These 3 satellites orbit Earth, precisely measuring magnetic signals from all over the planet. The data feeds into crucial tools like the World Magnetic Model, updated every 5 years. The 2025 update incorporates all the latest changes, ensuring navigation systems worldwide stay as accurate as possible. Researchers are also developing better radiation shielding for satellites, creating more sophisticated models of Earth's core, improving space weather forecasting, and designing hardened infrastructure that can withstand magnetic disturbances. So let's cut through the noise and get to what scientists actually think. Yes, Earth's magnetic field is weakening. The South Atlantic Anomaly is expanding. The magnetic North Pole is behaving unusually. These are real, measurable phenomena happening right now. But no, we're not facing an imminent collapse or catastrophic reversal. As paleomagnetist Robert Coe puts it, the dipole may be stumbling, but it's far from a collapse. Here are the key takeaways. Earth's magnetic field has lost about 9% of its strength over the last 2 centuries and about 30% over the past 3,000 years. The current weakening could represent a temporary excursion rather than a full reversal. The probability of a pole reversal in the next 20,000 years is only 2, and even if a reversal begins, it would take thousands of years to complete. The immediate concerns are technological, not existential. Satellite infrastructure, power grid vulnerability, and navigation system accuracy. Humanity has the technology and knowledge to adapt to these challenges. We are not our ancestors from 41,000 years ago seeking shelter in caves. We have advanced monitoring systems, predictive models, and the ability to engineer solutions. The story of Earth's magnetic field is a reminder that our planet is alive and constantly changing. The forces that protect us are dynamic, not static. And while that means dealing with uncertainty, it also means we're living on a geologically active, fascinating world. Scientists will continue monitoring these changes through missions like SWARM and future observatories. Each new dataset brings us closer to understanding the complex dynamics of Earth's core. The magnetic field isn't collapsing, it's changing, as it has throughout Earth's history. And just as life has adapted and thrived through hundreds of previous excursions, we'll adapt to whatever comes our way. What do you think about Earth's changing magnetic field? Does it concern you? Or do you find it fascinating? Let me know in the comments below. And if you learned something new today, hit that like button and subscribe for more science content that matters. Thanks for watching, and I'll see you in the next video.